Hi, good evening, friends. Good evening to all of you. Now, welcome to the Gradeup YouTube channel of Gradeup. I am Gourav Gupta, and I welcome all of you to our next session, where I am covering the basic step so that you can increase your percentile in QA section. Now, yesterday we have covered one of the topics, that was basics of factors and multiples, wherein we have seen some of the formulas pertaining to that, and we have seen some basic concepts as well. Now, friends, in today's lecture, I will be going through another basic concept, that is HCF and LCM. Now, like I told all of you yesterday, that these are some concepts that I'm taking, which generally students tend to neglect, tend to cram, okay, and they don't put a lot of focus on these topics. All right. So one such topic is HCF and LCM. Now, basically, all of us know how to find HCF and LCM, but generally we don't know, we don't understand the basic applications of LCM and HCF. Okay, and we generally tend to commit some basic mistakes when the questions of LCM HCF appears in our examination. Obviously the concept is simple, but the questions that you will see are not that simple. They are basically based on the applications of HCF and LCM. All right, so now let's start with this topic of HCF and LCM. Okay, now before we'll start this class, this is basically the YouTube schedule that we follow on our YouTube channel of Gradeup. So you may take a snapshot of this, and in case you want to attend any of these lectures, please do attend them live. All right. Okay. Now, friends, before I start with the basic concept of HCF and LCM, I would like to go back to the previous lecture, yesterday's lecture, wherein I covered some of the basic formulas. So let's quickly revise those three formulas, okay, before moving on to HCF and LCM. Okay, now the formula number one was number of, how to find out the number of factors of a given number. Okay, the first formula, number of factors of a given number. So the first step towards this was, we will write the number as prime factorization, okay, or the product of prime factors. So we'll convert the number in prime factorization. So let's say the number after converting to prime factorization is p1 raised to the power a multiplied by p2 raised to the power b multiplied by p3 raised to the power c, and so on, where p1, p2 and p3 are the prime numbers. Then we can say that the number of factors of this number will be equal to a plus 1 into b plus 1 into c plus 1. All right, so the students who are not there in yesterday's lecture, they may go back and revise this lecture. All right, am I clear? Okay, so this is the first formula. Now the second formula was related to the number of ways in which a number can be written as the product of two factors. All right, so number of ways in which a number can be written as the product of two factors. This is the next formula. All right, now this formula was, number of ways was number of factors divided by 2. But if you remember, I have told you two different versions of this formula. Now the first one was when n is a non-perfect square. All right, when n is a non-perfect square, then we know that the number of factors will be an even number. So to calculate the number of ways, what I can do is I can apply the simple formula, number of factors divided by 2. All right, now the second version of this formula was when the number is a perfect square. Okay, when the number is a perfect square, so in this case the number of factors will be an odd number, and the number of ways can be written as number of factors plus 1 whole divided by 2. All right, so I hope all of you remember all these things. All right, okay, right. Now these were the two first formulas that we have seen. Okay, the third formula, which I told all of you that this formula will be used in today's class. Okay, so it was number of ways of writing a number as the product of two co-prime factors. Okay, So the formula was, number of ways of writing the number as a product of two co-prime factors was 2 raised to the power n minus 1, where small n, this number, was the number of prime factors of the number. All right. So I'll take a quick example for this one because we are going to use this formula in today's lecture. So let's say after prime factorization, the number is 2 raised to the power 3 multiplied by 3 raised to the power 4 multiplied by 5 raised to the power 7. Okay. So let's say this is the number. Now, number of ways of writing this number as the product of two co-prime factors is 2 raised to the power n minus 1. Now, in this case, the value of n, so n is the number of prime factors. All right. So the number of prime factors here is 1, 2, and 3. So the value of n here is 3. Okay. So number of ways will be 2 raised to the power 3 minus 1. And that is 2 raised to the power 2, which will be 4. Okay. So to write this number as the product of two factors which are co-prime with respect to each other. Again, I'm stressing on this particular fact. The number of ways of writing this given number as the product of two co-prime factors is given by this formula. So in this case, there are 4 ways of writing n as the product of two co-prime factors. All right. Okay. Now let's start with today's concept. So the first basic thing that we need to know is how to calculate LCM and HCF of two given numbers. Okay. Now this concept is a very basic concept, and in general a lot of you will know how to calculate LCM and HCF of two given numbers, but still we'll just quickly discuss. We'll spend 2-3 minutes on this. Okay. So the first step is, whatever the numbers are, convert or write the numbers in the form of prime factorization. All right. So write the numbers in the form of prime factorization. This is the first step. Now prime factorization, we have already seen it yesterday. All right. So the very easy concept, the very basic concept. Now after converting or after writing the numbers in terms of prime factors, let's say the numbers are, so I'll take a small example of these two numbers. So the first number, let's say, is 2 raised to the power 3 multiplied by 3 raised to the power 4 multiplied by 7 raised to the power 2. This is the first number. The second number, 2 raised to the power 4 multiplied by 5 raised to the power 3 multiplied by 7 raised to the power 1. All right. Now let's say these are the two numbers. Now, first of all, to calculate LCM of these two numbers, what we'll do is, now what LCM is? LCM is the least common multiple. So basically the smallest number which is divisible by both n1 and n2. Again, the smallest number which is divisible by both n1 and n2. All right. So this is LCM. So in case to find LCM of these two numbers, what I'll do is I'll write all these bases. Okay. So the bases which are appearing in these two numbers, I'll write all of them. All right. So 2 is there, 3 is there, 5 is there, and 7 is there. Okay. So I have written all the bases. Now looking at the powers, just select the highest powers of these bases. So if I'll talk about the base 2, the highest power of 2 in these numbers is 4. So I'll write 4 here. Okay. The highest power of 3 is only present in the first number. So the highest power of 3 is again 4. The highest power of 5 is 3 and the highest power of 7 is 2. Now multiply all of them and this will be the LCM of these numbers. All right. Am I clear? So let's see if anybody has any kind of doubt. All right. So everything is clear to all of you. All right. All right. Let's go ahead and look at the next concept. Okay. So LCM, once again, I'll repeat. What I've done is I have taken all the bases and I have selected the highest powers. So LCM is all bases with their highest powers. Now let's move on to calculate the HCF. Now while writing the HCF, I'll just select the common bases. Okay, so common bases among these two numbers are, so 2 is the common base and 7 is the common base. All right, so 2 and 7 are the common bases. After taking the common bases, just select the lowest powers of these common bases. Okay, so the lowest powers of these common bases, so lowest power of 2 here is 3. Okay, so among the two powers, the lower one is 3, and for 7, the lower one is 1. All right, so highest common factor will be common bases with their lowest powers. All right, so this is the best and the fastest way of calculating LCM and HCF. Okay, so I'll repeat once again if you want to note it down. LCM के अंदर क्या करना है? We'll write all bases with their highest powers, and for HCF we'll write common bases with the lowest powers. Okay, so this is what you can see. For LCM, all bases with their highest powers, and for HCF, common bases with their lowest powers. All right, fine. So this is one simple way of calculating LCM and HCF of two given numbers. Okay, now the same thing can be applied for 3 numbers or 4 numbers. So the concept will remain same, the method will remain same. Okay, even if you have 3 or more numbers. All right, okay. Now let's move on to understand how to calculate LCM and HCF of fractions. So I'll not be wasting a lot of time on this. So LCM and HCF of fractions agar calculate karna hai, so you can just follow this particular method that is given on this screen. All right. Now you have to note down one thing, whatever the number of fractions are given. So you will have to first of all write all the fractions in their simplest forms. Okay, so please note down this particular thing. Okay, so this is an important note that you need to follow. So write all the fractions in their simplest form. This is one thing that you'll have to take care about. Okay, now after writing all the fractions in their simplest form, when we are calculating LCM, so here just consider the numerators and denominators separately. Okay, so to calculate LCM of fractions, we'll separately calculate LCM of numerators and we'll divide it by HCF of denominators. Okay, so LCM of fractions is LCM of numerators divided by HCF of denominators. Okay, secondly, HCF of fractions, highest common factor of fractions, is equal to HCF of numerators divided by LCM of denominators. ठीक है ना? So अगर LCM कैलकुलेट कर रहे हैं तो न्यूमरेटर में LCM आएगा, HCF कैलकुलेट कर रहे हैं तो न्यूमरेटर में HCF आएगा. Okay, so this is how you can remember these two things. All right, but don't forget to write all the fractions, convert all the fractions in their simplest form. All right, am I clear? Okay, so any doubt up till this point? Anyone? So if you have any kind of doubt, you may write in the comment section. I can see all the comments. So in case you have any doubt, please write it. All right, so no doubts. So let's move ahead and look at the next thing. Now, let's have a look at some of the properties which are related to LCM and HCF. Okay. Now, property number 1. Now, basically, this property is applicable when we are dealing with two numbers. So, if we are dealing with two numbers, let's say N1 and N2, so you can always say that the product of LCM and HCF will be equal to the product of the two numbers. All right. So the product of LCM and HCF will be equal to the product of two numbers. This can be always taken. Okay. Now, important is this property can be applied when you are dealing with two numbers. Okay. So this property will not be applicable, or I'll say that this property will not always be applicable in case you have three numbers. All right. So in case of two numbers, it will always be applicable, right? Okay. Now let's move on to the next property, property number 2. Now if the numbers are co-prime, so जिन numbers का हम LCM HCF calculate कर रहे हैं, if these two numbers are co-prime, okay, then yesterday we have seen what are co-prime numbers. Co-prime numbers are those numbers which don't have any common factor except 1. Okay, so I can easily say that the highest common factor of two co-prime numbers will be equal to 1. All right. So if the numbers are co-prime, their HCF is equal to 1. Now what will be their LCM? Now we have just seen one of the properties, property number 1, which says that HCF into LCM is equal to the product of two numbers n1 into n2. Now if HCF is equal to 1, then we'll obtain LCM as the product of the two numbers. All right. So we can say that if the numbers are co-prime with respect to each other, their highest common factor will be 1 and the least common multiple will be equal to the product of the two numbers. All right. Okay. Now moving on to the third property. If one of the numbers is the multiple of other number, okay, so let's say n1 is equal to 8 and n2 is equal to 24. All right. Now if this is the case, one of the numbers is multiple of the other number, then I can say that the highest common factor here, so what is the highest number that can be taken common from these two numbers? That will be the smaller of these two numbers. Okay, so highest common factor will be smaller of these two numbers and least common multiple will be the larger of these two numbers. All right. So these are three basic properties that you need to understand. Okay. All right. Now the basics of LCM and HCF are over. All right. Now let's have a look at some of the very important questions pertaining to the properties of LCM and HCF. Okay. So with these questions, you will understand the basic application of LCM and HCF. Okay. So let's move on to the first question. So first question is on your screen. HCF of two numbers is 4 and their LCM is 20. So there are two numbers, LCM and HCF given hai dono ka. Now the question is, how many such pair of numbers are possible? Okay, so you'll have to tell me how many different pair of numbers are possible with these two given conditions. I'll give you a minute to solve this question. Quickly get me an answer. Come on. All right, any answer? Pragya, Kavish, Monal, Anuj, Pratishtha, come on. Okay, Satyam is the first one to give the answer. All right, Satyam. Okay, so I'll explain you how to basically solve this question and then I'll give you a similar one. Okay. Now the question says that HCF of two numbers is 4. So highest common factor of two numbers is 4. So I'll assume the numbers n1 and n2 as 4x and 4y. Now let us first of all understand why I have assumed this thing. Okay, so Satyam has changed this answer. All right, no problem. Hi Yashasvi, hi Abhishek. Okay, now the first element of this question, highest common factor of two numbers is given as 4. Now, since 4 is the common factor, or I can say that 4 is the factor of both the numbers, so reversibly, both the numbers will be the multiples of 4. So, if 4 is the factor of any number, then the number will be the multiple of 4. All right. So, I have assumed n1 and n2 as 4x and 4y. That means the multiples of 4. Okay. Now 4 being the highest common factor, 4 being the highest common factor of these two numbers, I can say that 4 is the largest possible number that can be taken common from these two numbers. I'll take an example for that. Let's say I have two numbers 24 and 28. So I can take 4 common from these two numbers. So if I take 4 common, so the first number will become 6 and the second number will become 7. Now from 6 and 7, I cannot take anything else common. Alright. So I can say that 4 is the highest common factor of these two numbers. Okay. Now what has happened after I have taken 4 common from 28 and 24? 4 common लेने के बाद whatever the leftover portion is, they don't have any common factor, and hence I can say that these two numbers are co-prime with respect to each other. All right, am I clear? So if I have assumed n1 as 4x and n2 as 4y, 4 being the highest common factor of these two numbers, the relation between x and y will be that they will be co-prime with respect to each other. All right, this is one very important fact you need to understand. Okay, so this is the backbone of this question. This concept is the backbone. All right, okay. Now I'll apply property number 1, which is product of the numbers n1 into n2 is equal to the product of HCF and LCM. So n1 into n2, that is 4x into 4y, is equal to 4 multiplied by 20. All right. So I'll get x into y as 5. Okay. 4 and 4 will get cancelled. Another 4 will cancel 20 and I'll obtain 5. So the product of x and y is equal to 5. This is the relation that I have obtained. And another thing that I already had was x and y are co-prime with respect to each other. Okay. So now I want one thing from your side. If x and y are co-prime with respect to each other, all right, and the product of x and y is equal to 5, then what will be the possible values of x and y? Come on, x और y की क्या क्या value हो सकती है? So x and y should be co-prime with respect to each other and their product is 5. So what will be the values of x and y? Quickly. Okay, so in this case, there is only one possibility, that is 1 into 5. Okay, so the value of x is 1 and the value of y is 5. All right, so if I'll put the values of x and y to find the values of n1 and n2, so the value of n1 will be equal to 4 and the value of n2 is 4 into 5, that is 20. All right, so there is only one possible pair which will have LCM as 20 and HCF as 4. All right. So Satyam, good. Kalavati, good. Both of you have given the perfect answers. So in this case, there will be only one pair which will satisfy the given condition. Okay. So I hope all of you have understood this. I'll quickly switch over to the next question. So next question, the value of LCM is a little bigger. Okay. Now try to deal with this one. I'll give you one entire minute, one complete minute. Go ahead. So here HCF is 4 and LCM is 720. Now please be careful while you are doing this one. Now since HCF and HCF is given as 4, so like the previous question, I'll start by assuming these two numbers as 4x and 4y. Okay, 4 being the HCF, the numbers will be 4x and 4y. Alright, so this step is exactly similar to the previous one. Okay, alright, fine. So here the relation between x and y will be, these two numbers will be co-prime with respect to each other. Alright, now I'll apply property number 1 which I have just taught you. So 4x multiplied by 4y will be equal to the product of HCF and LCM. So HCF here is 4 and LCM is given as 720. So upon solving this, I'll get the value of the product of x and y as 720 divided by 4, that is 180. Alright. Now I hope all of you must have solved up till this step. Okay, so up till this step there is no problem at all. Now Satyam has given the answer. Okay, now Satyam, let's see if your answer is correct or not. Okay, now one way of finding the values of x and y is by using the method of hit and trial. So I'll write all the possible cases in which 180 can be written as the product of two numbers, if you remember yesterday's class. Okay, so x and y का product 180 given है, so manually I'll write all the possible ways of writing 180 as the product of two numbers, and out of those ways which I'll mention, I'll select those ways in which x and y will be co-prime with respect to each other. But obviously the method will be very lengthy. Okay, so I cannot manually write all the possible ways. I can do that, but definitely it will take a lot of time. So what we'll do is we'll use the formula, the third formula that we have done in yesterday's lecture, and the formula we have just discussed at the beginning of this lecture as well. So the formula was number of ways of writing a number as the product of two co-prime factors. All right, so let's go ahead and use that formula. So I want to find out the number of ways of writing 180 as the product of two co-prime factors. For that, I'll have to first of all convert 180 as the product of prime factors. So 180 में से 2 common लिया 90 आ जाएगा, again 2 common लिया 45. So 2 square multiplied by 3 square multiplied by 5 raised to the power 1. So this is prime factorized form of 180. All right. Now number of ways of writing 180 as the product of two co-primes, 2 raised to the power n minus 1. Here the value of n is 3. Now those who have joined late, just go back and have a look at the initial part of this lecture. Also, you may attend yesterday's lecture, which was conducted at the same time. All right, that lecture was about the factors where I have explained all these formulas in detail. So 2 raised to the power 3 minus 1, that is 2 raised by 2, and answer will be equal to 4. So yes, Satyam, your answer was absolutely correct. All right. Okay. So here we have a total of 4 ways of writing 180 as the product of two factors which are co-prime with respect to each other. All right. Now each of these four ways will give you one pair for the values of n1 and n2. So we can say that the answer for how many such pairs are possible, the answer will be equal to 4. So there are 4 possible pairs such that their HCF is equal to 4 and LCM is equal to 720. All right. So using this method, you can deal with any question of this type with the bigger values. All right. Am I clear? Okay, so let's quickly move on to the next question. The question is on your screen. Satyam, other students, Monal, Kalavati, Anuj, try to solve these questions. So how many pairs of natural numbers, both less than 100? Now carefully, both the numbers should be less than 100. So you'll have to find out how many pairs of natural numbers such that both the numbers are less than 100 are there, such that their difference is 49 and their highest common factor is 7. I'll give you 30 seconds to find this answer. Come on, quickly. Now you may start this question in the similar manner the way you have seen the previous two questions. Okay, so since highest common factor is given as 7, HCF is given as 7. So you may start this question by assuming the numbers n1 and n2 as 7x and 7y. Okay, again the same relation will follow between x and y, that they are co-prime with respect to each other. All right, now you may make your equation using this. The difference between the numbers is 49. So I can say that 7x minus 7y will be equal to 49 and x minus y will be equal to 7. All right. So now this is one relation that I have already obtained between x and y. So the difference here, now earlier in the previous questions, I obtained the product of x and y. Now in this question, I have obtained the difference of x and y, and here the difference is 7. Okay. Now one relation which is same between x and y as the previous two questions is that x and y are co-prime with respect to each other. Okay. The values of n1 and n2 are 7x and 7y, and x minus y is 7. Now I'll use this equation x minus y is 7, and I'll find the values of x and y using trial and error. Okay, so I'll just write manually the values of x and y. Now there is a limit for these two numbers n1 and n2 that their values should not go beyond 100. All right. So let's start writing the values of x and y such that their difference is 7. Now the smallest possible values will be 8 and 1. 8 and 1 का difference 7 होता है. Now 8 and 1, are they co-prime with respect to each other? Yes, they are. 9 and 2. So just keep on moving one step at a time. So 9 and 2, they are co-prime with respect to each other. 10 and 3, they are co-prime. 11 and 4, they are co-prime. Guys, make sure that you are checking if x and y are co-prime with respect to each other at every step. Okay. Now 12 and 5, yes, they are co-prime with respect to each other. Okay. 13 and 6, yes, they are co-prime with respect to each other. Now I'll simultaneously check this condition that both the numbers should be less than 100. Now if 7x and 7y both should be less than 100, then what can be the maximum value of x and y? X and y का maximum value कितना हो सकता है? 14. Okay. So 14 can be the maximum value of either of x or y. All right. So if I'll write 14, yes, I have reached to the maximum value, and y is 7. But in this case, x and y are not co-prime with respect to each other. So I'll stop here. So 1, 2, 3, 4, 5, 6. 6 different pairs of values for x and y will give me 6 different pairs for the values of n1 and n2. All right. And hence this is the answer for this question. So answer is there will be 6 pairs possible. All right. Am I clear? So we can say that this question is very, very easy. All right. Yes, Satyam, again you have given a correct answer. Wonderful, Satyam. Good. All right. Now let's move on to the next thing. Next question. Again, a very easy question. So the product of three numbers is 1620. If the HCF of any two out of the three, carefully deal with this statement. If the HCF of any two out of these three numbers is 3, then what will be the LCM of these three numbers? Take a few seconds. Now, a very easy question if you will focus on the second statement. If the HCF of any two out of the three numbers is 3, find their LCM. So again, you can start by assuming the values of these three numbers. Okay, so the HCF of any two of these three numbers, so I'll assume the numbers as N1, N2 and N3. So N1 and N2, if I'll consider these two numbers, then it is given that their HCF is 3. So I'll assume N1 as 3x and N2 as 3y. Again, if N2 and N3 are considered, then I can say that again their HCF is 3. So I'll assume the value of N3 as 3z. Alright, okay. Also it is given that N1 and N3 ka bhi HCF 3 hai. Okay, so their values are 3x and 3y already. Okay, so Satyam has given the answer. So Satyam, let's see if this is a correct answer or not. Now here N1 and N2 are co-prime with respect to N1 and N2, their HCF is 3. So I can say that X and Y, they will be co-prime with respect to each other. Also, the HCF of N2 and N3 is 3. So Y and Z, they will be co-prime. And so does X and Z. Alright. So I can combine these three statements and can say that X, Y and Z, these three numbers will be co-prime with respect to each other. Alright, this is one thing. Alright, now since X, Y and Z are co-prime, they don't have any common factor. I can say that LCM of these three numbers will be equal to 3 times X into Y into Z. Alright, so LCM of these three numbers will be thrice of X into Y into Z. 3 kahan se aaya? 3 is common here. Okay, and X, Y and Z, they are uncommon. They don't have any common factor. So all three X, Y and Z will be included in the LCM. Okay, so LCM is 3 times X into Y into Z. It's now just that we have to find out the value of the product of X, Y, Z, which will be substituted here to calculate the LCM. Okay. Now the first statement says that the product of these three numbers is 1620. So that means 3x into 3y into 3z is equal to 1620. So I can write that x into y into z will be equal to 1620 divided by 27. Alright, 1620 divided by 27. Alright. Now, what will be the value of x, y, z now? Satyam, would you like to check your answer? So, x into y into z का value क्या होगा? 1620 upon 27. इसका value कितना है? The value is 80. Alright? Fine. Oh, wait. The value will be 90. Okay, so the value of x into y into z will be equal to 90. Right? So, wait. I'll just quickly calculate it once again. So x into y into z ka value will be 1620 whole divided by 27. Alright. Now 27 into what number will give you 1620? 27 into what number will give you 1620? Anyone? Come on, anyone? Come on, guys. So is it 80, is it 90, or is it 70, or is it 60? I just want to see the presence of all of you in this lecture. All right, so I'm writing it. The value will be 60. So Satyam, you need to check your answer. Garvit, good. So x into y into z will be equal to 60. So now I'll substitute the value of x into y into z here. So 3 into 60, your answer will be equal to 180. All right. So answer will be equal to 180. That is the LCM of these three numbers. All right. So answer will not be 270. Answer will be 180. Okay. Now let's move on to the next question. A very, very conceptual question applying the logic of LCM. Now question says that if the least common multiple LCM of the first 100 natural numbers is equal to k, if LCM of the first 100 natural numbers is equal to k, then what will be the LCM of first 105 natural numbers? Now you have to write this value in terms of k only. Okay, so LCM of the numbers from 1 to 100 is given as k. Okay, now in this case you have 4 options given to you. So you'll have to find the LCM of first 105 natural numbers. Come on. A very easy but conceptual question. Okay. Now if I look at the given statement which says that LCM of first 100 natural numbers. So 1, 2, 3 up till 100. This is equal to k. Sorry, this is equal to k. All right. Now I'll not directly look at the LCM of 105 numbers. I'll add or I'll consider the numbers after 100 one by one. So LCM of first 100 numbers is given as k. Okay. Now I'll include one more number, that is 101. 101. All right. Okay. Now 101, is this number a prime number or not? Come on. 101 prime hota hai ya nahi? Just write yes or no. Now Garvit has given his answer. So Garvit, you are saying that answer will be none of the above. All right, we'll check in a few minutes. So 101, is it a prime number? Yes or no? All right, so 101, yes, it is a prime number. Okay, fine. So LCM of first 100 numbers is already given as k. Now 101 is a prime number, and any factor of 101 is not present in the LCM of first 100 numbers. Okay, so 101 being a prime number is not included while taking the LCM of the first 100 numbers. So I can say that LCM of numbers starting from 1 up till 101 will be equal to 101 multiplied by k. All right, so I've just considered one number. Since 101 was a prime number, then this 101 will be multiplied with the LCM of previous numbers to obtain the new LCM. Okay. Now, moving one more step ahead, I'll consider the next number, which is 102. Now, 102 is basically 2 into 51, or I can write it as 2 into 3 into 17. Okay. Now 2 is already present in the first 100 natural numbers. 3 is also present in the first 100 natural numbers as well as 17. Okay, so to now calculate the LCM of first 102 natural numbers, I will not include 102 because it is already included among the factors. All right. So LCM of first 102 natural numbers will remain same. That is 101 multiplied by k. Now let's include the next number, which is 103. Now is 103 a prime number? Yes, 103 is a prime number. Okay, so 103, yes, it is a prime number. All right. So since 103 is a prime number, so this value 103 will be multiplied by the LCM of previous numbers to obtain the LCM of first 103 natural numbers. So first 103 natural numbers का LCM कितना हो जाएगा? 103 multiplied by 101 multiplied by k. Okay. Now I'll consider 104. 104, if I'll factorize this number, this is basically 4 into 26. Okay, 4 is also present, 26 is also present. If I'll consider 105, this is 5 into 21. So in the previous numbers, 5 and 21, both the numbers are already present. All right. So if I'll include 104 and 105, they will not make any change as far as LCM is concerned. So I can say that LCM of first 105 natural numbers will be equal to 103 into 101 into k. All right. Now 103 and 101 को multiply करेंगे, it will come out to be 10403 times k. All right. So this will be your final answer, and answer is option number 3. All right. Sanket is asking, sir, this will help in MHCT or not? Yes, Sanket, these concepts. So MHCT के जो questions होते हैं, if you have seen any of the papers of MHCT, now the questions of MHCT are not very lengthy. So they are like less lengthy questions, and they are basically based on these small concepts like LCM, HCF. So whatever I'm teaching you in this lecture, whatever I have told you, I have taught you in this lecture, this will definitely help you in MHCT as well as any other entrance examination that you are sitting for. All right. So Satyam and Nikunj, both of you have given the correct answer for this one. So yes, our answer will be option number 3. That is 10403 multiplied by the LCM of first 100 natural numbers. Now why 10403? Because 103 and 101 both were prime numbers, and they will be included to calculate the LCM of the next 5 numbers. All right. So if I'll consider the next 5 numbers, from 101, 102, 103 up till 105. So only the prime numbers will be included, and they will be multiplied with the LCM of the previous terms. All right. Okay. So friends, that's all from my side for the day. So today we have seen the concepts of LCM and HCF. All right. Now about tomorrow's lecture. Tomorrow I'm going to take up a very difficult topic, that is factorials. And in tomorrow's lecture, I'll be telling you how to basically calculate the power of any number in a given factorial. So as in, like if you're given 100 factorial. So in 100 factorial, if you want to calculate the power of 2, the power of any prime number, or the power of any composite number. So this is what we'll be dealing with in tomorrow's lecture. All right. And there will be some tricky questions that have appeared in previous year's ZAT or CAT papers. All right. So we'll see you in tomorrow's lecture. Now here is some of the important things that I want to discuss. So in case you want some regular updates to be coming from my side, you can note down my number and you can WhatsApp me these details. Okay. And I'll be giving you constant updates of all the upcoming sessions. All right. Okay. Now, in case you like this session, please press the like button, comment and share and subscribe our channel. All right. Now, if you'll subscribe our channel, you will definitely get the constant updates of all the upcoming sessions. Now, this is one thing that I've also told you yesterday. Now we have made an arrangement where all of you can have an easy access to all the free lectures at one place. So these lectures will be on all the topics of CAT, MHCT and the other entrance examinations. So you don't have to search for the lectures of independent topics on YouTube. Okay, so we have made a sheet. All right. Now using that sheet, you can have an access of all the lectures. So in that sheet, if you'll open it using this particular link, and the link is also sent to you in the comments. Okay, so the link is also sent to you in the comments. So you can take the snapshot of this link. If you'll click on this link, this will redirect you to one of the sheets where we have segregated all the topics and we have provided the YouTube links in front of all those topics. So if I talk about the concepts of numbers, so you can have an access of all the concepts of numbers on this sheet. All right. Okay. Now further, some information about the batches which we have already launched in the month of August. So this was a batch which was launched on 13th of August, and these are the details. So this batch was for CAT 2021, a percentile booster course with the following set of mentors who will be teaching you in this batch. Now for CAT 22, we have another batch. Okay. So this was batch 4, and the complete details are given to you, which was launched on 4th of August. Now further, we are going to launch another batch for SNAP, NMAT, CMAT and TISNET preparation. So those who are focusing only these examinations, just look at the right hand side of the screen and the details are given to you. You may go ahead and join this batch. The different courses that are offered at Gradeup. So some CAT courses and the courses for other MBA examinations. Now this is the set of mentors, set of experts other than me, which are there with Gradeup. The super subscription plans for CAT 21 and CAT 22 and the other MBA examinations, the different examinations that will be covered here, the validity of these courses and all the inclusions, like what all things will be included, are given here. All right. Now next is all from our side. You can follow us on Instagram, Facebook, join us on Telegram, okay, and do subscribe our channel. All right, friends. So that's it from my side for the day. Have a good day, keep solving, and we'll see you tomorrow.